Good afternoon, everyone. It is a very hot afternoon. I hope that you're all feeling good, and I think most of you are studying for your exam the next week, coming week. Okay, but I hope that you are able to spend just about maybe less than half an hour with me just to complete my today's lesson. So today I'm going to cover 10.3 and 10.4. Okay, so without further ado, I'm going to share screen. I hope you can see this. Right, I'm going to explain some important concepts on the mechanism of heartbeat and also the mechanism of blood clotting. Okay, I'm going to cover these two topics for today. All right. Okay, let me see who is here with me. Okay, Cikgu Rahima, is it? I'm not sure whether it's student or are you a teacher? Rahima Ibrahim. Okay, good afternoon. Good afternoon. Callisto, good afternoon. All right, so I'm going to start lessons now. If you have any questions, please do ask me questions if you need to. All right, let me start by, okay, sorry, let me share screen. Oh, you already shared, huh? Okay, let's start. Right. Now, mechanism of heartbeat. All right, sorry, what happened here? Okay, right. Mechanism of heartbeat. Okay, let's look at the mechanism of heartbeat. All right, now, here we will see that the heart has a particular rhythm, okay? Everybody is familiar with the sound, right? Later I'll let you know what the sound is. The sound actually sounds like lub-dub, lub-dub, and so on. So what makes the heart beat, okay? So the heart is actually made up of a type of muscle. That one you learned it earlier in your chapter 2, I think, chapter 2 or chapter 3. Chapter 2, okay, where you learn about the different types of muscles, or different type of cells or tissues. So you have something called the cardiac muscles. So these cardiac muscles are only found in the heart. They're only found in the heart. And their function is to contract and relax rhythmically. And then the purpose is to pump the blood, make the heart pump the blood out, okay, and also receive blood into the heart. Okay, so they are actually made up of cells which are interconnected. So they intersect and they're interconnected. So you can see here, this is, if you see this diagram, you should be able to recognize that this is a cardiac muscle. Okay, cardiac muscle. So it is not the skeletal muscle, neither is it the smooth muscle. So you should be able to recognize this is the cardiac muscle. Okay, and if you look under the microscope, this is what it should look like. Okay, you see the nucleus, they are multi-nucleated, okay, and also you find that they are interconnected. Okay, so these are the cardiac muscles. Okay, so these cardiac muscles, the adaptation. Why are they interconnected? So it's to allow electrical impulses to spread rapidly through the heart. So because if they're interconnected, then the impulse can easily spread to the other cell and so on. Okay, so that will initiate the trigger, they will trigger the heart muscle to contract. Okay, so the impulses will stimulate the cardiac muscles to contract simultaneously, means together, and uniformly, means at the same time. Okay, it has a certain kind of rhythm to it that after you will see. Okay, let's look at this. Okay, now you see the heart pumping away. This is quite slow, right? Probably at resting heart rate, right? You will see that the atrium, okay, after the atrium contracts, it will be followed by the ventricles. So it has a certain kind of an order to how they contract. All right, okay. So cardiac muscles, we have this word now, we call it myogenic. So this is a characteristic of the cardiac muscles. When we say that muscle or the cell is myogenic, that means it is able to contract and relax without receiving impulse or message from the nervous system, from the outside. That means it's able to carry on, start its contraction and also relaxation on its own without receiving impulse from the nervous system that is outside. Okay, so that means if you give this heart, you take out the heart, you sever means you cut away the blood vessels, all right, the blood vessels that connect, you know, the vena cava, the aorta, and then the pulmonary arteries and the pulmonary veins. You take out the heart out, all right, from the body of the person or an animal, and you put it in a condition where you are supplying it with oxygenated blood, okay, and also with nutrients. They can actually contract and relax on their own. Okay, you do not, because you already cut it away. So it's no longer connected to any nervous system. It is able to contract and relax rhythmically on their own. So that's why we call these muscle cells, these kind of cells are myogenic. They're able to contract and relax on their own. So you see, it's rather scary, right? Okay, some of you do not like to see blood and so on. So this is what happens if you can take out the heart and you to supply oxygenated blood, right, through the heart muscle. It will be able to contract on its own. I've seen this on a video where the person has actually removed the heart of the frog, freshly remove it, and even though it's disconnected from the body, okay, of the heart of the frog, it is still able to contract on its own for a few good minutes before it dies out, because there is still oxygen inside the blood there. Okay, so it's able to contract on its own just for a few minutes before it finishes the supply of oxygen. Okay, now, so we have seen the word myogenic. So now you can see there is a rhythm to it, okay? The up here is, these are the we call it the atrium. So you see the atrium and the ventricles, they will contract alternately. When the atriums contract, the ventricles will relax. When the ventricles contract, the atrium will relax, so that the blood will be able to flow in and out. Otherwise, if everything starts to contract, all right, you find that the blood will be going out. There's no way of the blood being refilling. There's no refilling of the blood into the atrium. Okay, so what causes the blood to circulate in the human? So the force that enables the blood to circulate, okay, is produced by, here you see the pumping of the heart. No? The pumping of the heart gives you the force to push the blood along. Okay, and another one is actually the contraction of skeletal muscles. So the blood vessels, all right, you have skeletal muscles. The skeletal muscles are the ones that are found in your limbs, your arms and your legs and so on. So when you walk, when you move parts of your body and so on, you're actually contracting the muscles, and the skeletal muscles squeeze. So when they squeeze, they actually press onto the blood vessels, and it actually helps to move the blood also. Okay, so these two things are the ones that contributing factors to making the blood flow in your body. All right, okay, let's go on to see the important part, which is the cardiac conduction system. How is the impulse started in the heart, and how is it connected? How is it transferred to the rest of the heart to initiate the heartbeat? Okay, so there's one place where the impulse is actually initiated, where it started. Okay, it doesn't start from outside the heart. In fact, there is a clump of cells here or tissues here, which we call the pacemaker. The contraction of the heart is initiated, means started. Coordinated means controlled by the pacemaker. So it's a very simple word. Okay, pacemaker is a group of tissues there. And the pacemaker, when we talk about pacemaker, we're actually referring to the sinus. We call it the sinoatrial node. Okay, SA node. So it's a group of specific heart muscle cells which is found at the right atrium, the upper part of the right atrium. So it initiates the rate of heart contraction and is located in the wall of the right atrium. Okay, somewhere up there. So you can see this is the sinoatrial node. All right, okay. So the impulse comes from there. The trigger to start the heart, to start pumping, comes from this SA node. We call sinoatrial node. Not sinoarterial, it's called sinoatrial node. Okay, let's carry on. Now, you can see very clearly the SA node is where the impulse starts from. And you can see it is carried over to other parts. So you can see it moves over to the left and the right side of the, let me try to write this. I can see here, it moves over to, okay, different color. It moves to the right and the left side of the atrium. It is conducted to the left and the right side of the atrium. Okay, so The contraction of the heart is initiated and coordinated by the pacemaker. All right, and this is where the sinoatrial node is. Okay, now so look at these two hearts, right? The one on the left is the normal heartbeat. You can see it's contracting in a very controlled manner. All right, it looks like the correct rate, which is around 70 to 80 beats per minute if you're at a resting heart rate. Okay, the one on the right has an abnormal heartbeat. You can see it's like jittering, you know, it is not really contracting. So this is an abnormal heart rate. Okay, something has gone wrong. Okay, maybe the conduction system, or maybe the sinoatrial node is not doing its job. So the pacemaker, there's something wrong with the pacemaker. So what we normally do is, if a doctor detects this kind of a problem where your heart is beating abnormally, maybe it's too fast or too slow, right? What you can do is the doctor can put in an artificial pacemaker. So this is an additional knowledge for you, okay, which you don't have in the textbook. This can come up in the KBAC question, all right, the higher order thinking skills. Okay, so there is something called an artificial pacemaker. It's a small electrical device that we embedded in our body here, all right, and sometimes you wear it just out on the skin of your torso, I mean your heart, the chest. It is to enable those who have arrhythmias. Arrhythmia is irregular heartbeat. Okay, irregular. Sometimes it's like jittering. It's not really contracting in the proper way. You find the ventricles are like, you know, vibrating, that kind of thing. So you don't have an what they call a productive kind of a force being produced. So the blood doesn't really travel very well. So the heart is beating too fast, or it could be too slowly. So we put in the artificial pacemaker to control the heartbeat. So you bring it back to normal. So it beats at the correct speed. Okay, so what they do is they have to do a bit of surgery lah, all right, and they have to connect this pacemaker. Okay, you can see some wires there, all right, it connect the pacemaker on this chassis. So anybody who's wearing a pacemaker, all right, you have to declare that you're wearing a pacemaker when you go through this electronic device and all that. You may have the beep 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 sound when you go through the checking when you pass through the airport and all that, all right. So you may have a pacemaker in the body, all right. Okay, so let's look at the conduction system. Okay, and this one is important for you to explain because it can be a question in your essay. It can also come out in the structure where you have to describe the cardiac conduction system, or you can describe the mechanism of the heartbeat. How does this impulse starts? How does it make the ventricle contract? Okay, so you can see all these dotted lines here. They show the electrical impulse traveling from the sinoatrial node, which is up here. You can see very clearly it goes over to another node. It's called the atrioventricular node. After that, it passes down to the middle here. All right, call it the bundle of His, and then goes down all the way to the bottom, which is called the apex, the tip, the apex, and it spreads to both the ventricles. Okay, so we're going to learn this now. So the main pacemaker is the sinoatrial node. So assuming that is normal, right? You don't have a problem with your heartbeat. So the pacemaker generates the electrical impulse. So the electrical impulse starts from the SA node, and it later on it's going to spread. After that, it spreads rapidly through both the atrium. So the atrium will contract first. If you notice the way that conduction is, the heart pumps. If the atrium contracts first, followed by the ventricle just a split second later. Okay, so there's a rhythm to it. So atrium contracts, just look at my hand, right? This is the atrium, the top one is atrium, and this is the ventricle. So when atrium contracts, the ventricle has to relax so that the blood can flow into the ventricle. Then after that, your ventricle contracts, the atrium will relax to bring in fresh supply of blood from the vena cava and also the pulmonary veins. So they come in, all right? So this one will contract. So you can see this. This is the alternating action. When the atrium contracts, the ventricle relaxes, and when the ventricle contracts, the atrium relaxes. So it goes like this. Okay, so I'm only showing one side of the heart because I don't have four hands to show you. So I can only show the atrium of the maybe right and the ventricle of the right. Okay, it's the same for the other side. The left also, both atriums contract together and both ventricles will relax together. Okay, that's how it works. Okay, so you can see here very clearly, both atriums contract the blood will be squeezed down, pushed down into the ventricle, and later when the ventricle contracts, the blood will the blood in both the ventricles will move up the aorta and also the pulmonary artery. Okay, so this one again you can see, and the cardiac conduction system, all right, you can see all these like electrical signals being passed on. Okay, so let's look at the notes. All right, there are 4 steps. Okay, so if you want to describe it, you have to put 1, 2, 3, 4. Okay, let's make it very clearly. Number 1, just now we mentioned where does the electrical this system starts from. This signal starts from where? It starts from the sinoatrial node. All right, so it's the first point. The sinoatrial node or the SA node generates or produces the electrical impulse. Okay, so it starts from there, and you can see that it will spread. Second step, it spreads rapidly to both atria. Atria is the plural of atrium, and this causes the atria to contract simultaneously. So the left and the right of the atria will contract together. Okay, now after that, what happens? This signal travels down. Okay, this signal, after passing over to the the atrium, this signal actually goes down from the sinoatrial node to another node, which is called the atrioventricular node, the AV node. The AV node is there somewhere in between the atrium and the right atrium and the right ventricle. Okay, and after that, you see this atrioventricular nodes. It will spread downwards through what we call the bundle of His. Okay, it's labeled here. And then after that, you see the Purkinje fibers, and to the apex. Apex means the tip of the heart. That's apex. So it goes all the way down. After that, it goes up. It curves up. Okay, the conduction moves up to the 2 walls, the walls of the ventricles. So the electrical impulse spread from the apex of the heart to both the ventricle walls, causing the ventricles to contract. So once the impulse comes here, it will make the ventricles contract and it pushes the blood out. And actually it goes into the aorta and the pulmonary artery. Okay, so this is how you should explain when a question asks you to describe the mechanism of heartbeat. You must use all these words. Okay, you must properly know what you're talking about, the sequence. So you can see, if we want to see whether our heart is beating correctly, okay, there's a test that the cardiologist can do or the doctors can do. They will attach a what they call a sensor, a few sensors on the heart here, and pick up the signals. So they call it an ECG. This is an electrocardiogram to show the wave pattern of the heart. So this pattern is the normal one, the normal heartbeat that has no problem. All right. So you can see very clearly, starts from the sinoatrial node, spreads over to both the atrium or atria, and after that it goes down the middle there, the septum, through the bundle of His and Purkinje fibers. After that, it will trigger the ventricles to contract. Okay, so that is the wave. Now this wave pattern you do not need to memorize. It's not in your syllabus. This is to show you this is the correct wave. Okay, the pattern that you should see if you have a healthy heart. Okay, next. Now this is from the textbook. All right. So if you were to write, these are the words that you should use. So this is, I've already used all this in my explanation just now. Okay. So number 1, it generates the SA generates the electrical impulses. Number 2, you say the electrical impulses spreads to both of the atria, causing the atria to contract simultaneously. Okay. And then this pushes the blood into the ventricles. Okay, and now the electrical impulse reach the AV node. And then this electrical impulse will spread downwards through the bundle of His, the Purkinje fibers, and to the apex of the heart. And after that, this electrical impulse will spread to both the walls of the ventricles, so both sides. And as a result, the ventricles will be triggered to contract the blood, and the blood will go out through the aorta and also the pulmonary artery at the same time. Okay, so this could be a question in one part of the essay where you can talk about the mechanism of heartbeats. Okay, right, this is we have to explain how the conduction system works, the electrical conduction system works. Okay, now sound of the heart. Okay, So you can see here, some valves are opening and closing. You see that? All right. What you look at the left, this one is the right, the heart is called the tricuspid valve. Okay, I'm going to draw here. This is the tricuspid valve, and this is the bicuspid valve. So you will see them closing together. So when that closes together, you will hear the first sound, which is the loop sound. Okay, so during the pumping of the heart, if you want to describe the sound of the heart, is the loop-dub, loop-dub. Okay, a loop and a dub, and then followed by a small sort of a rest. Okay, the space there, loop-dub, then loop-dub, loop-dub. Right. So when the loop is produced, the sound of loop is produced by the closing of the heart valves. That means the bicuspid. Okay, the loop-dub valve is together. Right. To be specific, the loop is for the tricuspid and the bicuspid valves closing together. So when you see this one, okay, wait, let me loop-dub, loop-dub. The dub comes from the, you see up here, this one is another one. This is the semilunar valves. It's at the base of the pulmonary artery, and another one is hidden here, is behind. It is the aorta, at the base of the aorta. So the dub is caused by the closing of the semilunar valves. Okay, so let me try to generate the, see, loop-dub, 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 loop-dub. Okay, you see that? All right, so the same thing happens here. The loop is when this one closes. There's my, this one. This is the loop. Loop, this is the loop, and the dub is this one. Okay, yeah, not very clear. Can you see the blue color, red color? This is your dub. This is the dub. All right, okay, so now you are clear. So first heart sound loop occurs when the atrial ventricular valve, referring to your bicuspid and your tricuspid valves. Okay, so this is the loop when it closes, right? And the other one, dub, is when the semilunar valve closes. That is the dub sound. All right, okay, now let's look at the phases of the heart. Now the heart has got two phases, all right? Actually, when it contracts and relaxes. So we talk about the ventricle contracting. So the first picture here shows the ventricles are smaller, okay, because they're actually contracting. When they're contracting, you can see that the blood is pushed outwards. You can see the semilunar valves are now open, but the bicuspid and tricuspid valves are closed. So now this instance, right, this is called the ventricles contracting, is called the systole. And this is the loop, when you have the loop sound. The loop sound is when these two valves close. That's the loop sound. Okay, and then after that, you find after contracting, your ventricle has to relax because it has to recoil. It has to fill back with blood and then to contract again. So you cannot be contracting all the time. You contract, you got to relax. Okay, so the next instant is when the ventricles relax. You can see it becomes, more relaxed. It's bigger, right? No more squeezing. That is called the diastole phase. Okay, diastole phase. So here, diastole is where you have the dub sound, because now you can see these semilunar valves are the ones that are closing. So there's the dub sound, right? And this is the diastole phase. Okay, when in systole and diastole, we are referring to the ventricles. When the ventricles contract, it's called the systolic phase. When the ventricles relax, it's called the diastolic phase. Okay, right, clear? Okay, I don't see any comments or questions, so I'll carry on. Now, returning of the blood to the heart, okay, especially for the lower extremities, okay, or the upper extremities, you go to the head and go to the feet, you have to come back to the heart, right? Now, there will be a slight problem when we're talking about the part of the blood that goes right down to the feet because of gravity. Okay, so the pumping of the heart is through the arteries. It's got no problem because it's got pressure. So the pumping of the heart will allow blood easily can flow to all the parts of the cell. Okay, it's the coming back that will have a slight problem. The going there is no problem because the heart pumping at high pressure, arteries carry blood at high pressure, so it's easy to reach every part of your body, okay, your body cells. But the coming back, we may have a slight problem because especially when talking about blood coming back from the feet, it is going against gravity. All right, it will be going against the pull of gravity. So sometimes the vein, the pressure will be too low. It is actually insufficient to make the blood flow back to the heart easily. Okay, so you need a bit of help. Okay, so the pressure in the blood is actually not enough to make the blood flow back. So you get to need additional help. Okay, what are the additional help that will do? Okay, number one is got valves. These are veins. These are the cross longitudinal section of the veins. So here, when the blood pumps through or goes through, all right, the valves is a one-way valve. So the valves will open, right, allowing the blood to go up. But after that, when it falls back, right, because of the pressure, gravity pulling it back, you find that because of the blood flowing backwards, it will help to close the valves. So close the valve, but because the valves are closed, it stops them from going further. Okay, so after that, it will go up again for higher a little bit, but it will drop back. Okay, so it will prevent the blood from actually going back to where it belongs. It will also go up actually, but slowly lah. Okay, eventually it will reach. The valves will stop the blood from flowing all the way back. Okay, it will go up a little bit, but then it will just stop there, and then go again and stop there, go again and stop there. So it will not totally go backwards. All right, so that is the function of the heart, the valves. Another one that help is the smooth muscles that is at the veins. Okay, but this is very thin. You notice, remember you learned about the thickness of the smooth muscles at the vein. This is quite thin, so it doesn't also apply enough pressure. All right, so not enough pressure, so we also need additional help to make the blood flow back to the heart. Okay, what is the additional help? The additional help is aided by, okay, your return of the blood to the heart is helped by your of course, just now I mentioned the smooth muscles, right? Smooth muscles. And another one is the skeletal muscles. So these are the muscles in your feet or muscles in your arms, which when you move, your muscles are going to contract. So the first picture here shows contraction of the muscles. When your muscles contract, right, they will squeeze. So you can see they squeezes the veins, so the blood will go up. Okay, once it go up because of the valves, it will stop. Okay, now after contracting, your muscle is going to relax. Okay, so the contraction will press and constrict the veins, causing the valves to open and the blood to flow upwards. Okay, after that, of course, after contracting, you have to relax. Now, once it relaxes, because of the valves, the blood will be, it will stay here. So it will not go all the way down. So that will help not stop the blood from going back all the way to where it belongs, to where it started. Okay, so because of the valves here. And the skeletal contraction, the skeletal muscles contraction actually help to give additional pressure to make the blood flow back to the heart. Okay, now here this is something additional which I've added in, which is of interest. It could also be something like hebat. Okay, have you seen people who have these very horrible veins in the legs? Okay, especially old people. Okay, I know because my mother-in-law has it. Okay, and it's quite obvious. It's quite obvious. You can see all these, snake-like kind of shape for the veins. These are veins, are not arteries. Arteries are much deeper. You can't see on the surface. Okay, these varicose veins have become look like very elongated, very loose, and they become not elastic. So it becomes a bit longer. That's why it goes windy like that. It becomes an S shape and so on. So these are twisted and large veins. They commonly are found in the legs, for the veins in the legs. It is because of probably prolonged hours of standing or walking and so on. So it will increase the pressure in the veins of the lower body, and also because of aging. Because of aging, your veins or your muscles and your everything, it gets less elastic. Okay, so your collagen, you lose collagen as you grow older. So it gets less elastic. So same for this, the elasticity of the veins. It becomes less elastic, becomes longer, elongated, and it becomes windy. All right, now, so what actually happens, you see all bulging out here, looks very horrible, right? So if you were to slice open the varicose vein, you will see that the valves are all distorted. Okay, so the valves do not function very well. The blood cannot be stopped from going backwards efficiently by the deformed valves. So the blood will not be able to be return as efficiently as someone who does not have varicose veins. Okay, so you can see here, normal vein will be this. You have the valves closing properly and the valves opening also. For varicose veins, the valves, most of them are open. Okay, so it does not really, it's not so effective in stopping the blood from flowing backwards. The valves do not close properly because they're damaged. All right, so what can be done about this? So number one, there could be surgery. That surgery can be done, right, to repair these varicose veins. Another one, if you do not want to do surgery, normally you wear certain compression kind of stockings, okay, where you press, okay, so it squeezes back the thing, so it will be applying pressure on your veins all the time. So you got to squeeze, you got to wear it for a number of hours in the daytime, so to help the blood to go backwards, okay, to not go backwards, to go up, okay. So it's to the pressure is to help the blood to move up lah. Okay, so the varicose veins may improve with compression. So you gotta wear all these special stockings, right? Okay, next. Now we go to 10.4. I'm finished with 10.3. Now, mechanism of blood clotting. Okay, so this one is quite straightforward. All right, this one also can have a question where you're supposed to describe the entire mechanism of blood clotting, how it starts to initiate. Okay, what initiates when there's injury? It will start the sequence of events, the chemical processes, okay, the biochemical processes, and ending up with trapping the red blood cell. The red blood cell does not move out, okay, so it's stopped. The red blood cell is stopped from going out of the wound. Okay, let's see. Now, first of all, why is there a necessity for blood clotting? Okay, number one, it is of course to prevent entry of microorganisms, right? When there's a cut in your blood, in your skin, it is a place where entry, microorganisms can enter, bacteria and virus will enter. So it may infect your body, you will have serious illnesses and diseases. So if you bandage it, okay, or the blood clots, when the blood clots, right, is like covering it, it will prevent entry of microorganisms. Okay, next, stop and minimize loss of blood. Okay, this is important because if you lose blood, your blood carries precious cargo. Your blood carries oxygen, it carries enzyme, it carries hormone, it carries antibody, it carries glucose and amino acid. All these things the cell needs. So if you have blood loss, these things cannot be passed on to the body cells. Okay, then the body cells will die, of course, when you don't have oxygen every day, every minute. Okay, next one more is to maintain blood pressure. So if your blood pressure drops, okay, the blood will flow very slowly. It is not efficient. The pressure is not high enough to allow the blood to flow to all the body cells in your body. Okay, so that is therefore is necessary for your blood to start to clot when there is injury. Okay, remember I say when there is injury, when there's no injury, that you should not have blood clotting. Okay, because if there's blood clotting when there is no injury, it will be a dangerous thing for to happen because your blood will not be able to carry, will not be able to flow. Your cells cannot get oxygen. Okay, only when there is injury, damage, then your blood should start clotting. Okay, and you also learned earlier in the previous lessons, the clotting of blood is actually helped by, you have this cell called platelet. Okay, so there's actually not only platelet helping, there are actually a sequence of events. There's a sequence of events that help the blood to clot in the end. All right, so you need to explain this. So the blood clotting involves a series of chemical reactions. So it's actually a biochemical reaction now that takes place when someone is injured. The purpose is to prevent excessive bleeding. Okay, you don't want your blood to lose, right? Okay, to go out. Okay, so now we need to remember and understand what are the series of events that takes place when your blood starts to clot or wants to clot. Okay, let's see. It involves platelets. You're going to mention platelets. You have to mention some plasma protein and also clotting factors. Okay, clotting factors, you don't need to know the names. They are quite complicated. These are special proteins that will initiate the clotting to happen. Okay, you have factor 8 and so on, number there. Okay, so let's look at, okay, so I've made a flow chart. So here you can see the injury on the blood vessel and you can see erythrocytes flowing out. So what happens is, first of all, your platelets will rush there, okay, and it will start to coagulate. Platelet coagulate means they get stuck together. It will start to, if the wound is not serious, your platelets will form a plug. It will stick there and will start to temporary plug. Okay, if the wound is very small, okay, so you have a temporary plug made by the platelet plug. Okay, so if it's more serious, you need to other measures, more drastic measures to stop the blood from flowing. So we're going to talk about it now. So coagulated platelets and damaged cell, and also clotting factors. So you have all these three things. These are the chemical processes, the interaction between coagulated platelets, damaged cells, and clotting factors. They will form, all right, something, an enzyme known as thrombokinase. Okay, how do I know it's an enzyme? Because of the ASE at the back. ASE is a general name for a lot of enzymes have the same name, right? Maltase, sucrase, and so on, the ASE. So another name is also called thromboplastin. So thrombokinase and thromboplastin refers to the same thing. Okay, so this is an enzyme, right, that will be formed when blood clotting is initiated. Okay, now when you have thromboplastin, all right, together with calcium ion that's in your blood, and also vitamin K, right, which is also in your blood. So these two, with the aid of these two things, your thrombokinase will trigger prothrombin. Prothrombin is a plasma protein, okay, in your this blood, right? Prothrombin, which is an inactive plasma protein. It's not activated yet, it's inactive. So you need the thrombokinase to activate your plasma protein. So this prothrombin will be converted into something we call thrombin. Just throw away the pro, all right? Thrombin is the active plasma protein. Okay, so you can see here, thrombokinase will convert prothrombin to thrombin. Okay, and that's not the end of the story, because your prothrombin is also needed to do something, right? Your prothrombin will trigger the conversion of fibrinogen, which is soluble. This is a plasma protein that is soluble in the blood itself, in the plasma of the blood, right? The liquid part of the blood. So this is a molecule that is quite large, is a plasma protein. Okay, this is soluble. It will be converted into something we call fibrin or fibrin, and these are actually insoluble. You will see all these lines, you see all this mesh, it forms a jaringan, we call it a network. It forms a netting. So this netting will trap the red blood cells, and now the red blood cells will be trapped there and it cannot escape. Okay, you can see here the fibrin is formed. Okay, so the entire sequence, you must know how to explain it in words, and hopefully you get full marks, right, if they ever do ask it. Now please look at this carefully. There's one what you call mistake that I normally see in students. They will write fibrinogen, which is wrong. Not fibrinogen, not fibrin, but fibrinogen and fibrin. So Fi, not Fri. So be careful, because when you use the wrong term, it is wrong. Okay, because you are expected to use the correct word. So this is wrong. Be careful, not fibrinogen, but fibrinogen. The R is put at the wrong place. So be careful where you put your R. All right, okay, clear, right? Okay. Next, let's look at health issues related to blood clotting. Okay. What if an individual have blood clotting even when they are not injured? Yes, it's life risk. Yeah, it's life threatening, Callisto. So normally there are certain people, yes, they will, because of aging, because of the complication in the blood and all that, they will have what you call a higher risk of blood clotting. So that's why they will have to have medication. So you see this thing here, heparin, right? You have heparin being sold in hospitals. They can dispense it, they can be injected, they can also take certain medication, they call it warfarin, to stop the blood clotting, so that the blood does not flow. The blood does not clot when there's no injury. So I personally have experienced it because my father was ill at one time. The doctor prescribed something, aspirin, I think, to stop the blood from sticking together and all that. So it's important that they have to take it every day. Okay. Do you need to memorize all the facts? Yes. What fact are you referring to? If you're referring to the mechanism of this one, yes. If you want to score, if you want to describe it, want to describe the mechanism. So the mechanism, you expected to explain the sequence of events from the coagulated platelets, the damaged cells, clotting factors, forming the thrombokinase, until the formation of fibrin to trap the red blood cell from flowing out. Okay, you expected to know this, explain this also. All right, okay, yeah. So I hope that helps answers your question. Okay, next. So let's go to look at this. Health issues related to blood clotting. So you see, under normal conditions, okay, just to answer Callisto's question, is related to what you answered just now, just now. Undamaged blood vessel, there will be people actually having, some doctors will say, I use it very simply, your blood is very thick, okay? They say your blood is very thick, that means there's a high risk of your blood forming clots. Maybe due to aging, maybe due to your composition of your blood and so on, all right? So the blood, under normal conditions, people who are healthy, right, it will not clot because we have this anticoagulant called heparin, which you learn in the red blood cell is being produced by basophil. Remember the white blood cell called called basophil. It produces heparin. It's also produced by the liver cells. Okay, so normal conditions, it should not clot. All right, that means you're healthy, you're fine. Okay, now 2 conditions. Okay, related to, is this topic familiar with essay question? Yes, I've seen it before in the mechanism of blood clotting. It came up before in the essay. You can expect it also. Of course, I do not know which year will come out, right? So it's better to be prepared lah. Okay, haemophilia is one of the conditions that you need to know. This is when the blood does not clot, even though there is bleeding. Okay, it's a hereditary illness. So it means it's passed on from generation to generation. It can be passed on from the mother who's a carrier, can pass on to the son. The son can be a haemophilia. Okay, this is a famous, in history, there's a family, the Russian, the king, we call it Tsar. They had a very famous, right, in this case, of the last king, because they were overthrown by these Bolsheviks, the people, they hated the king, they all executed the entire family. There were 4 girls and 1 boy. So the youngest boy, okay, his name is Alexis or something. So he was haemophiliac. Okay, any injury, the whole household will be up in uproar because he will be bleed non-stop. And there's one person who can stop it. There was a monk by the name of Rasputin. I'm sure some of you will know that, okay, if you have your general knowledge about these things. Okay, so back to the thing. So they do not have this clotting factor. They lack of certain clotting factor. They cannot make, their body cannot make that clotting factor. They cannot produce that clotting factor because they don't have the gene for it. Okay, so they have a recessive gene, which is that causes the haemophilia. That one you learn in Form 5, the recessive gene. Okay, so this heparin, right? This haemophilia will stop. Means blood cannot clot generally. What it means, if a haemophiliac patient, someone who is haemophiliac, will not be able to clot. The blood will not clot easily. Not easy to clot. Okay, so what happens if you have anybody who is haemophiliac, who's injured? Quickly bring to the hospital. All right, because only the hospital, the medical staff can do something about it. They will inject clotting factors into the body. No matter how much you aid the person by wrapping, applying bandage and so on, it's not going to stop bleeding. Okay, so excessive bleeding due to small wounds, it can also result in death because it will not stop bleeding. You can't do anything. You have to bring to the hospital. All right, quickly. So the other case is the opposite. Just now cannot clot, right? Cannot clot. This one is clotting while the person, there's no injury. Just like the Callisto was saying, okay? This is life-threatening because your blood clot will form in the arteries or in the veins, okay? Probably due to some problems in the inner wall of the veins. So this is formation of the blood clot. Now the blood, what's the difference? Thrombosis and thrombus. Thrombosis is referring to the kejadian, the phenomenon, the thing that happens is called thrombosis. Okay, thrombus is the clot itself. The thing that you see there, this is thrombus. Okay, so don't mix up your thrombosis. Don't know when to use thrombosis. Don't know when to use thrombus. Thrombus is referring to the clot itself. Okay, so this is formation of blood clot, even though when there is no, when there's not, even though when there's no injury. Okay, so thrombosis is caused by, what could possibly cause thrombosis? Damage in the blood vessels. So it causes the blood, the red blood cells to stick together easily in the blood vessels. Sluggish blood flow. Sluggish is slow. The blood flowing slowly, okay, causing the clotting factors to accumulate. So when the clotting factors accumulate, then it will initiate the blood clotting. All right. So next one. Now, so just now is a blood clot is called thrombus, and the kejadian is called thrombosis. All right. Now, so let's look at another one. This is called embolism. Now, embolism very similar to thrombosis. It's just that in this case of blood clot, the blood clot broke off from the thrombosis. It broke off, means a small little piece broke off from the thrombus there, and it starts to move. So it's a traveling blood clot. Okay, the traveling blood clot is called an embolus. Embolus is referring to the clot that travels. And then embolism is the kejadian, the phenomenon. The phenomenon where a blood clot travels is called embolism. Okay, and this is dangerous because when your blood flows, right, is from the artery to the arterial will go to capillary, right? Capillary is very, very fine. So sometimes the embolus will get lodged. It can start to travel now because the blood vessel is still very, very wide. But once it comes to a capillary, which is very, very small, it will get lodged there. It will get stuck there. And the blood will totally not flow into that part of your body. Okay? So when that happens, your cells there will not get enough oxygen. If it happens to your brain, you will have a stroke. Okay? We call in BM, we call angin ahmad. So this is what happens when people have a stroke. There's a blood clot somewhere in the blood vessel that supplies oxygen and nutrient to the brain. So it stops there, and the functions of the brain, all right, will not work because there's no oxygen. The cells are not, the brain cells are not oxygenated. They are not able to perform. They're not able to carry out the function. So therefore, when you have a stroke, sometimes depends on what happened, which part of the brain controls what. Sometimes you have people cannot speak, slurring of the speech, talking, they cannot mouth, they cannot articulate properly because of stroke. All right, that part controls speech. Or maybe that part of the brain controls the right side of the body. Maybe it happens in the left hemisphere. If the stroke happens in the left hemisphere of the motor part of the brain that controls the movement of your arms and your legs, then your arms and your legs cannot move. Then you're paralyzed, one side of your body. You have to drag it along. Okay, you can't walk properly. Maybe your left side still okay, your right side cannot. Okay, so that is a stroke. Okay, in Chinese we call it 中风, right? 中风, right? Then if it happens on the coronary artery, the coronary artery are the blood vessels that supply oxygen to the cardiac muscle. You can see on the outside of the heart there, a lot of blood vessels there. That is the coronary artery. If it gets stuck there, the embolus gets stuck there, or after the blood vessel, you have these cardiac muscles, you will not get oxygen. So these cardiac muscles will not know how to contract. And there you have a heart attack where your heart fails to pump. Your heart fails to contract. Okay? And you call that myocardial infarction. This is a medical term. If you see, they will shorten it to MI. We call it MI, means it's like literally it's a fancy word for heart attack. Okay, the heart just stopped pumping, or it's pumping irregularly. Okay, all right. So I have covered what I wanted to cover. All right, I hope that next week. Oh, sorry, there's some diagrams to show you thrombosis. The difference between thrombosis and embolism. So thrombosis is just a blood clot there. All right, this happens. We call it deep vein thrombosis. Is in the feet now. Okay, where you have, the varicose veins, complicated by varicose veins and so on. And embolus is when it travels. So this is called embolism. Okay, embolism is the phenomenon when the blood clot travels. Thrombosis is just when it clots only. Okay, so it is a GIF here to show how the valves help in stopping the blood from flowing backwards. All right. Okay, so this is what I want to sampaikan for you today. All right, hope you've understood 10.3 and 10.4. So I hope to see you next week, okay, with more lessons to complete chapter 10. All right, okay. So let me check if I have any questions. Okay, so far no questions. All right, thank you very much for watching, and you can share this link to your other friends so that they may be able to benefit as well. Okay, hope to see you next week then. Okay, bye-bye everyone. Thank you for watching, and see you next round. Okay, bye-bye.